Hello, this is Bhupendra Singh and I welcome you all to my YouTube channel Jagram EduTech. And this is a practice question series based on optics first chapter reflection of light. And this series is going to continue to the chapters and units of mechanics and electricity and magnetism. And in physics, these three units actually forms a major area for competitive exams of CDS and DA. Okay, so to learn the concepts in detail and to strengthen our basics, numericals becomes okay a very important part of our preparation. So here I'm going to take some numericals to solve okay in front of you, and let's take the first question. Here the question is that the spherical mirror produces a magnification of -1 on a screen placed at a distance of 50 centimeter from the mirror. Okay, the question wants to find out okay that what type of mirror is being used in this particular situation, and the distance of the image from the object, and the focal length of the mirror. Okay, and also we can draw the diagram of this particular uh, formation here. Okay, so we are going to take one particular scenario here. Okay, I'm going to choose this, and let's see. Here the magnification is actually given as -1. Okay, from our fundamental and basics we know that in case of concave mirror, okay, in case of concave mirror my magnification is negative, and in case of convex mirror, okay, convex mirror my magnification is positive. Okay, so the magnification given here is negative. That means I can deduct one particular, I can deduce the result from this that the mirror used is of concave nature. Okay, so first thing is cleared. Now second thing, as it is shown that magnification is -1, okay, and the magnification formula is minus v upon u. That means v equals to u. Okay, it means the image is at the same distance where my object is placed at. Okay, and in concave mirror there is only one scenario where the object is at the same distance where the image is. Okay, and that particular situation is at the center of curvature. So if I'm going to draw my diagram like this, I'm going to take a concave mirror, I'm going to polish it from outside. Okay, and this is my focus and this is my center of curvature. If I put my object here, okay, I'm going to choose two types of rays. One is parallel to the principal axis, then it is going to pass from the focus. And second, if I will take, if I a ray passes through focus, it is going to be parallel to the principal axis. That means okay, the intersection between these two rays is going to give us the point of image. Okay, so right here is our image. If AB is our object, then A dash or AB dash is going to our image. Okay, so in this particular situation, okay, our object is at the same distance as okay where our image is. Okay, so here the distance between the image from the object is actually 0 because both are at the same place. Okay, and if we want to find out the focal length of the mirror, so we know the formula here given or in the fundamentals as r equals to 2f. That means radius of curvature is defined as the twice of the focal length. Okay, so here radius of curvature is 50 centimeter. Okay, so my focus is going to be -25 centimeter. Okay, so we have the result here and we have solved this particular question, and I have given you the ray diagram for this image formation. Okay, so let's proceed to the next question. Here the question says that the linear magnification produced by a spherical mirror is +1/3. Since the magnification is given as positive, I'm going to consider that the type of mirror which is used here is of convex nature. Okay, convex type mirror is used here. Okay, if I'm analyzing this particular value, okay, then I can deduct the position of the object with respect to the pole of the mirror. Okay, as magnification is minus v upon u. Okay, so here my v is actually going to be -1. Okay, and u is going to be 3 because the result is and since object is always minus 3 because it is in front of the mirror, okay, and the image is actually behind the mirror, so together it will form positive ka 1 by 3. Okay, so it means that my image here minus v upon u is equals to 1 upon 3. That means minus 3v is equals to u. My object should be at a place which is 3 times of the image. Okay, so from the pole of the mirror, the image distance is 1 and the object distance is 3 times of the image distance in front of the mirror. Okay, so that is our answer. So let's proceed to the next question. Here the question says that an object is kept at a distance of 4 meter in front of a spherical mirror, okay, which forms its erect image at a distance of 1 meter from the mirror. Okay, and it wants us to find out the magnification. So let's see the formula here we are going to use is magnification is equals to minus v upon u. Okay, and we know that v is given as 1 meter from the mirror, that means on the right side of the mirror, so it is going to be as minus and 1 inside v. Okay, and u is given as 4 meter, that is going to be on the left side, so it is going to be as negative 4. Okay, so the whole equation is going to be 1 upon 4 over b, that is also of positive. So magnification is positive 1 by 4. It means that the mirror we are using is of convex nature. Okay, and the magnification here is 1 upon 4. Okay, so let's proceed to the next question. In this question, a concave mirror produces a 3 times magnified image on a screen. Okay, and here it is given that the object is placed 20 centimeter in front of the mirror, and how far is the screen from the object, that is the question asked. Okay, so in this particular situation, first what I'm going to do, I'm going to examine the scenario that my actually image is magnified here. So we already know that out of concave and convex mirror, only concave mirror is actually responsible for the magnification, because in convex mirror we do not get any magnification. Okay, so if the image is 3 times as large as the object, okay, so it means my magnification is actually minus 3. Okay, so my formula is going to be minus v upon u. So here if I place this value, and u is already I know minus 20 centimeter, so my formula is going to be minus v equals to minus 3, and value of u is minus 20 centimeter. That means v is going to be minus minus positive, minus will go this side, that means minus 60 centimeter. Okay, so if I am going to place my object at a 20 centimeter, my image is being formed at minus 60 centimeter on the same side. And how far is the screen from the object? We can actually get this particular result by subtracting the value of object from the image v minus u, that is 60 minus 20, that is 40 centimeter. Okay, screen is actually 40 centimeter away from the object. Okay, so that's it for today, and in next series or next video we are going to take up more questions, and we are going to solve a lot more questions based on this. This series will go on, and we are going to learn a lot about physics in this way, because numericals is a great way to understand the depth and the basics, okay, of concept.